G'day, so today we're talking about kinematics. So kinematics is the study of how motion works with particles in space. So what we're looking at in terms of kinematics, we're looking at how an object relates to its initial placement, how it looks in terms of its movement, and how it's moving in terms of its speed. So when it comes to kinematics, there are three different types of variables that we need to deal with. The first variable is what is commonly known as S of t. And this here deals with the displacement of the object. Or another thing we call it is called the position of the object. We have our velocity function, which is v of t, and this here measures the velocity of the object. And then we have a of t, which measures our acceleration. So acceleration, which measures how fast an object is moving. So when it comes to the kinematics, our initial function or our position function tells us where that function lies. So for instance, if we were looking at a line diagram here, and just say this here was our origin, and just say this here is where S of t is after p. So we could say that the origin is travelled p units away from the origin. And if it was negative p, we move to the left. So when it comes to position, if p is greater than 0, so look at position again. If p is greater than 0, we go to the right. If p is less than 0, we go to the left. And if p is equal to 0, it means we're at the origin. Okay? So when we're talking about the position of our particle, we're talking about how it looks in terms of where it's placed in respects to the origin, where the origin being 0. When it comes to the velocity function, the way that we find the velocity function is by taking the first derivative of our position function. So therefore, v of t is equal to the derivative of whatever s of t is. And the velocity function is telling us how fast something is moving in terms of time. Okay? And it's generally put in terms of centimeters per second to -1, meters seconds to -1, kilometers per second to -1, so such. But that -1 is that rate in terms of its speed per second. And acceleration is the derivative of v of t. And again, this here has per second. And what this basically is telling us is how fast, what the speed it's moving. So this is telling us how it's moving in terms of its velocity. This here is telling us the speed it's actually moving at. And when we look at kinematics, these are the three functions that you work with most of. So there are some more terms that we need to remember when it comes to kinematics. And they are, if we want to find the initial point. So the initial point is when t is equal to 0. So we wanted to find where the initial point was for our position, our velocity, and our acceleration. We replace the t with 0 in each of those equations, and that will tell us those initial points. And we write it up in terms of what it looks like. So if p was greater than 0 for s of t, we'd say it's to the right of it. If it was positive or negative, we talk about if it's increasing or decreasing, moving to the left or moving to the right by that centimeters. And we then talk about its acceleration in terms of the signs. So that takes me to this next part here, that if a of t, we'll do it again, if a of t has the same sign as v of t, then we say that the particle is increasing in speed. Increases in speed. So that only happens if the signs are both the same. So for instance, if we had v of t was equal to negative 12 centimeters and a of t was equal to 6 centimeters, then we would say that speed is decreasing because they're not the same sign. One's negative, one is positive. However, a lot of times we look at sign diagrams that tell us how that works. Another thing that we need to remember when it comes to kinematics is know when a particle is changing. So we know that the particle changes direction when v of t is equal to 0. Now we've seen this here before somewhere. We've seen that in terms of a stationary point. And we know that we can work out the stationary point when we take the derivative of our initial function and equate it to 0. Well, that's what we're doing here. We're just deriving our position function to get the the velocity function. And if I equate it to 0, that's going to give me where it changes direction. So basically where it's going from max to min, or min to max. However, in this case, when we draw our diagrams, we're actually drawing a motion diagram, which is a side way of looking at the graph. But it changes direction when our vector equation is equated to 0. And the last thing here is, if we have, for instance, if v of t is equal to 0, and that's what your t was equal to, at that exact instant, it's at rest, at that exact instant time. So if t was equal to 0, we would say at that point, we know that we've got a particle sitting at rest. So when we're looking at kinematics, it's the study of movement of a particle using our understanding of derivatives. And the three things that we deal with when it comes to kinematics is the position function, how it looks in terms of the origin, the velocity, how far is it moving away or from the position, and acceleration, is it speed, is it increasing or decreasing. So this is what we're going to be looking at over the next couple of videos. So I'll see you in the next one.